Okay, then we will start today. Welcome everyone. I'm Arsen. We have worked with Jonty to get this up and running. We will talk about the Connected Vehicles Accelerator. The agenda for today will be at the very first part. We will speak more in terms of the concepts behind the scenes. Then in the middle of the session, we will speak more from the technical standpoint, and then finally how to transform this into a solution and how to sell it better into our potential customers. What is the Connected Vehicles Accelerator? This is a set of TIBCO tools tied all together in order to create a vertical solution. This is not only TIBCO tools, but it's also a solution. In the core of the solution, we have the GTFS format for transit vehicles, which is a specification to make the transit data public and universally accessible. And this vertical solution, this accelerator, provides three key elements, which are the visualization, the dashboards to see the real-time vehicles moving across the map, different rules to detect unexpected behaviors or just expected behaviors and monitor that correctly. And also the integration between the different components and make it work all together. What is the business scenario? What we have now in this area of business without the accelerator? Typically, in this kind of companies, of areas of job, we have isolated systems that model roads, maybe isolated system for schedules, and different elements that are not tied together. For example, we can have historical data, but in batch systems or processes, and we will not have the ability to predict accurately. We can have data in silos or in different networks, are mainly batch-oriented feeds. So we can say that we have now the data in the wrong place at the wrong time. And that is what we will solve with this accelerator, with this vertical solution. At the very first, we can say that in the era of Internet of Things, each vehicle is a mobile device. So we can speak about the Internet of Trains, Internet of Boats or airplanes. So this is an important opportunity to increase the information, either in quantity and in quality. We have advanced engines that if we can put the key data in the correct place, we can have better information in time. And also this it's in some place dangerous because the volume of the data that we can gather today, the amount of devices moving on each second across each city. So we will need a very advanced smart processing event tool. This will allow us to make predictive analytics, and it's also a good opportunity to add a new way to monetize our information generated by the data, for example, using the real-time APIs. Let's try to start introducing the Connected Vehicles Accelerator. At the very core of the solution, we have the trip. The most important element is the trip. But also we have all the elements that makes the trip possible. For example, the vehicle, for example, the crew, the passengers, or the cargo, and also all the processes that are around of that. For example, the contracts, the working time of the persons, the weather, any different process that it's around each company and each contract. At the very high level, talking about the interactions, we have data from our own systems. For example, the location of the vehicle. We can combine that with real-time feeds. For example, the weather and the traffic, and we can analyze all of that and produce automated actions. The automated actions can be produced for internal purposes or also for outside parties. This data, it's used also for the real-time analytics and the real-time dashboards that we will use to monitor and to action anything that we want. This picture illustrates what we were talking about, the key concept of the whole solution. We have the passengers or cargo, we have the vehicles that make the trip possible, and the crew that also makes the trip possible, and all the processes. Let's speak more about what the process means. We have at the left pane, the process can be, for example, the fleet management. The vehicle must be up and running, must be working. We have a process to sell tickets, over internet or over, I don't know, personally. We have manifests, we have operations, we have planning. All of that means the processes. In this side, we have the 4 components, the trip, the crew, and the passengers. We have the external information like the weather and the traffic. And the connected vehicles accelerator ties all of that together and generates 3 kind of outputs, which are the automated actions, those actions that we don't want to spend human time to take on. We can just deliver to them to the streaming tool to automate normal and expected actions. We can get in a more advanced machine learning or artificial intelligence piece. We can just throw advices and then also alerts if an unexpected behavior is happening. Let's speak about what is composed. What about the components of the accelerator? This is organized into different contexts. A context means a specific possible solution. Each possible solution, it's like a skeleton of the solution that ties each piece together, but also it needs a simulation piece. The simulation piece must be inside a use case. We can simulate, for example, an unexpected journey. We can simulate, for example, an unexpected journey, an issue, anything. That means that we have context, 3 contexts, and for each context, we have different test cases and simulations. We have 2 different dashboards. For monitoring purposes, we have live view dashboard. For each of these 3 contexts, we have a live view dashboard to work on. And we have also an extra Spotfire dashboard, which is for configuration purposes. Speaking about the context, we have 3 different solutions or contexts. The first one is the distribution logistics. It's for any logistic company, or in this case, it's a logistic company located in Bay Area that are providing deliveries from the factory or the sources to different stores. The second one will be a railway company delivering passengers from in Netherlands. And the third one is the secure logistic. It's also a logistic company, but the key feature here is the security of the things that are transported, because the distribution logistics is focused on the passengers, but the secure logistic is focused on the elements that are expensive. We are using simulations. In here, we don't have, ideally in a real case solution, this will be connected and the input data will come from the devices, GPS information, all of that. In this case, everything is simulated. The simulation in this case includes the vehicle speed, the direction, the distance, the position, and the occupancy. And all the UI, it's based on live view. This is a picture of the, I don't know if you can see this correctly, but at this side, we have the data sources that are simulated for this solution, but should come in a real case, use case, will come from the sensors and devices located in each vehicle or passenger. The first piece that the stream base uses is the data adapters and transformation that they come to messaging bus, which means we need the enterprise message bus from TIBCO. Then the stream-based workflow is processed in the stream-based event flow message server. And then the output data is pushed into live data mart, and finally into the real-time dashboard, which are everything in live view. We have a Spotfire dashboard also, but it's only for configuration. These are the components that we need to set up and deploy and change if we need to adapt this to a specific solution. We have the TIBCO Enterprise Message Service to get the messages from different devices and put into the stream-based server. We have patterns, we have Spotfire, we have TIBCO Streaming, and the Artifact Management Server to get up and running the different models that works here. Finally, working about what we will see in the demonstration that Jonty will do in 5 minutes. The distribution logistic includes a Spotfire dashboard to change the simulation conditions. This is a logistic company in the Bay Area that distribute from different centers to different stores. And we have, for example, one of the use cases that we have, it's a full day service day, which means we'll have multiple vehicles with multiple passengers going through different roads. We can change, one of the things that are inside here in terms of machine learning is the Clark and Wright savings algorithm for vehicle routing planning. We can change from Spotfire the conditions of the centers and the stores, and this algorithm will be executed again, and the routes will be calculated again. For the railway, we have a virtual train running. We have different test cases to show different scenarios, like unexpected stops or skipped stops. This is a very interesting list of different scenarios. And finally, in secure logistics, the most important key feature in here is the geofencing rules. We have a geofence that we can monitor if the vehicle is going inside the geofence, and in case of the vehicle goes out the geofence, an alert will be thrown. We have, this is useful, for example, for all of that trips that needs a valuable things going inside it, like the banks or ATMs. And we have also multiple simulation scenarios, the expected and unexpected scenarios. That's the theory. We will see more in detail what that means in terms of a demo. So let's continue speaking about that with Jonty in 5 minutes. For now, in order to close these slides, I will speak about the effort required to transform this into a real use case, a real deployment, a real solution. About the sizing, keep in mind that we have 3 different contexts or 3 different possible solutions that we can sell separately. We have 6 types of components: the core elements that are the skeleton of the solution, the inputs that are everything simulated in this case, but in a real use case, this will be many different devices running in many different environments that we need to transform and put into Streambase. We have the outputs that are basically like data mart tables. This will not change mostly unless the customer requests a different solution. We have the simulations elements that in a real case will be out of scope. We have the DXP dashboards and the live view dashboards. We have involved 6 typical platforms: Spotfire, LiveView, Streambase, EMS, Patterns, and AMS. We need to deploy everything. We need to create a development environment for each of these one and deployment production environment from all of these. We worked in an initial estimation, not based on a real plan, but based on the experience of the author of this accelerator and the experience of what involves the streaming development. This we should start thinking about 3 months of engage. We need to install all of this environment. We need to design, we need to develop, we need to test, we need to deploy. We need to adjust the scope in the process, but this should not be less than 1,000 of hours. Some tips to see what we need to take care in order to transform this into a pre-sale process or attempt. We need to add some kind of Genware information in the slides. We need to reference what TIBCO Spotfire and TIBCO streaming means, because this is based on those 2 platforms, and we need also to sell the license for these platforms. I suggest to change the simulation reference to templates or to skeleton reference. We suggest, I also suggest to change, instead to speak about accelerators, speak about a solution or a product.
Austin?
Yeah.
Okay, just take a breather. Just a quick thing over there. When we deal with the accelerator itself, that's fine. But remember that when we're demonstrating it, it's fine to use it as an accelerator. But when we productize this, we'll probably turn it into something else. And the way we're labeling our products is as a blueprint. So it will become so it goes from an accelerator to a blueprint.
Okay.
That later on, but I just wanted to give that some context since you were speaking about that. Okay.
Okay, makes sense.
Thank you.
Well, and finally, propose a long-term engage, like around the 1,000 of hours. At a very high level, we need to install each of 6 TIBCO platforms in dev and prod environments. We need to install the accelerator in each platform. We need to plug each connector and each output into customer data sources. We need to customize metadata like maps or roads and names. We need to do testing. We need to deploy. And we need to define clearly, position clearly that this also involves devices programming, because at the end, if the company have 1,000 of vehicles and 10 different types of devices running up in each vehicle, each interface, each access point should be configured to connect and to call through EMS into our environment. And this will require probably a specialized provider that works on drivers, on GPS or geocoding. Some list of possible markets in which this solution can be applied. For example, the remittance transport, the ATMs, logistics, the public transport, also owners of a large fleet of vehicles. If you have 100 of taxis or 100 of Ubers, this could be useful. Transport of passengers, logistic companies, private security. I know that right now any police agency already have a similar solution for this. It can be for police, but also for private security. postal companies like the EHL, school buses, or also splitting by type. This can be applied for trains, flight, cruise ships, or buses. Now I will bypass the control to Jonty that will show us all of these three contexts, the live view dashboards and the Spotfire dashboard. Jonty, go ahead.
Great, thanks, Austin. Okay, in this part of the presentation, we're going to have a look at a demonstration of the live view dashboard. This is part of the Connected Vehicles Accelerator and is hosted by the Accelerator. When we first launched this live view dashboard, we are presented with this login screen where you would enter a username and password and then go about selecting your specific context. As mentioned previously, we have three different contexts: the distribution logistics, the virtual train, and the secure logistics context. We'll start off by examining the distribution logistics context. Logging into the live view dashboard, we are presented with the home page. And by default, we are presented with a map visualization. This map visualization shows the San Francisco Bay Area, along with the various coffee bean distribution centers, as indicated by the blue building icons, and a chain of coffee shops, which are identified by the gray dots on the map. If we go ahead and select one of the distribution centers, we'll get a very limited view of the specific distribution center. However, once we start a simulation, we'll get far more information about the different trips that come through this distribution center and are labeled by their departures and arrival times. So let's go ahead and do that. To start a simulation, we're going to open up the simulation control panel, which you can find in the top right corner, indicated by these two dashes. Opening the simulation control panel, we get a view of the status of the simulation, which is currently stopped, as well as the actions that apply to the specific simulation. You may also notice the service date. However, the service date has no relevance on the demonstration context as of yet. So going forward, we'll select today's date. And the first test case that we're going to have a look at is an on-time full service day. As we can see from the description, it's just a full day of operations. So let's go ahead and start this. Once the simulation is started, you'll notice the time compression slider appear. This allows us to control the speed of the simulation. By moving the slider to the left, we are able to slow down the simulation speed, and moving it to the right would, of course, increase the simulation speed. Let's navigate back to the map and have a look at what we can see. You'll now see that all of the different trips going from the distribution centers to the various stores will appear in our trip list on the left. We can filter these by selecting a single distribution center, for example, the Fremont distribution center, whereby we'll only see those trips that originate from this distribution center. You could also type into the filter box and see only certain trips. Let's clear that out. And as you'll see on the map, we've started to see the different trips starting to take place and the vehicle starting to move. Let's go ahead and select the first trip. By selecting the first trip with a single click, you're able to see the planned route from the distribution center to the various stops. The stops are, of course, identified by these purple circles. Let's go ahead and double click on the trip to get some more detailed information. This opens up the trip details view. As you can see here, we have our distribution center listed as the departure location, and we can see the different stops that the vehicle will make along this planned route before returning back to the distribution center. This visualization, map visualization, allows us to view this in real time, as you would have on the home screen. However, we do get additional information here. For example, the departure times shown in the right column and the arrival time shown in the left column. These also display the various delays, if any, shown by the green number, green or red, depending on whether or not the vehicle is delayed. We can also see the status of the vehicle in terms of whether or not it is delayed. As you can see on the left here, this vehicle is currently on time on this route. We can also view additional metric information, such as the current speed, the bearing or heading, and the distance traveled from the distribution center. Moving on to the Vehicles tab, we get an idea of the cargo capacity for this vehicle. As you can see in the vehicle diagram displayed on the right, we can see how loaded this vehicle is, and we get an indication of that on the left, saying it is partially full. As the vehicle moves from stop to stop, this information will be automatically updated. Let's move on to the Cruise tab. From this Cruise tab, we can see all the crew members that are involved in a current trip. As you can see, there's just one single driver for this trip and this specific context. We can see that he originated from the Fremont Distribution Center, and we have access to the shift ID. Moving on to the Consignments tab, we get an idea of the kind of products that are being delivered. So here you can see we have different types of coffee beans that are being delivered from the distribution center to the stores. These are also labeled by their relevant status. So once these products have been delivered at the store, they will change to unloaded. If we navigate back to the Location tab, we can see that this vehicle is still on its route towards to the first stop. And although this context is relatively simple, it does allow us to examine the integration between Spotfire and Streambase, where Spotfire is required for route network planning and the Accelerator is required for tracking the deliveries. I'm now going to open Spotfire, specifically the distribution logistics analysis file, and our tabs of interest would be these constrained optimization and operations tabs. On the constrained optimizations tab, we can see the routing that takes place between distribution center and the stores. Currently, the context has been configured to have 7 active stores. If we wanted to change this to, for example, 5 active stores, we could then recalculate the optimal assignments, which would then eliminate 2 of the stores from the list, and then therefore recalculate the route that should be traveled from those distribution centers to the stores. As you can see now, the number of deliveries by distribution center has changed, as well as the driving distance information. You should then be able to push this through to Streambase, and it would automatically reconfigure itself for this test case. Unfortunately, this deploy routes is not working at the moment. However, if we navigate over to the Operations tab, we can get some additional information and real-time information. Here you can see the number of trips that are busy taking place, similar to those seen in the live view dashboard. However, if we select, for example, a specific trip, we can get metric information for that specific trip. For example, speed over time, delays over time, cargo loading or unloading over time, as well as the number of trips by a specific status and the distribution by distribution center. This is just to demo the integration that can take place between Spotfire and Streambase. Moving back to Streambase, the live view dashboard, we will now change over to a new context. In order to do this, we will now terminate the currently running simulation by using the simulation control panel. After this, we'll log out and log into the new context. The next context to be discussed will be the secure logistics context. In this context, we're looking at a high-value delivery company in Madrid. By default, you see again that we have a map visualization. However, it's centered around Madrid, and we have some different information being presented. For example, the purple house icon shows the virtual logistics depot. This is where the vehicles would leave from along their trip and return to afterwards. You may also notice the lightly shaded yellow areas. These have been identified as high-risk areas and are likely to fall on the routes that the vehicles travel. But let's see this in action. So again, I'm going to open up the simulation control, select a service date. And for this, the first test case, I'm going to do a on-time single trip. As we can see from the description, it's just a single trip that departs from the depot, collects the secure cargo from the first stop, and then proceeds to 3 delivery locations before returning to the depot. I will adjust the time compression to try and speed up the simulation slightly. Moving back to the home screen and clicking on the first trip, we see that we have some extra information now shown, or different information shown on the map. Firstly, we can see the single trip, the planned route, which is shown by the purple line. Secondly, we have a lighter shaded purple area. This is the permitted service area where the trip may operate. Anything outside of this perimeter will register an alert as it deviates from the originally planned route. Let's go ahead and view the details of this trip and talk about what else we can see. So here we see at the various stops, there are red circles that surround the stop. These are marked as secure locations where the vehicle may stop. If the vehicle has to stop outside of these, it will again register an alert, which could be sent via multiple communication channels to the end user. We will demonstrate how these alerts are raised in the next test case. You may have noticed that as the vehicle passed over the high-risk area, we have received an alert in the bottom left. This can also be seen by the bell icon in the top right. By clicking on the alert code, we'll get some more information about what has just happened. You can see on the right-hand side here, we see the descriptive text saying that the trip has entered a high-risk area. Again, we see another high-risk entry alarm as it has entered another one of the high-risk areas. Navigating back to the trip details, let's go have a look at the Vehicles tab and make notes of something. Here you see the 2 vertical black lines on the side of the vehicle diagram. These will be useful in the next test case as we will demonstrate what happens when a vehicle stops outside of a permitted stop zone and the doors open to trigger an alert. As you can see here, we have a driver and a guard under the Cruise tab, which makes sense for this current context. Moving over to the Consignments tab, we can now see that instead of coffee beans, we have cash boxes as the type of cargo being being moved around from location to location. As you see, the status is unloaded as the cargo has been offloaded at the relevant locations. Moving over to the next test case, we can terminate this current test case and just reset to clear the data. This next test case is going to have a look at what happens when those doors are opened outside of the secure areas. So we'll select rules, single trip, perimeter door open. As you can see from the description, the vehicle will halt unexpectedly for about 30 minutes and the doors would be open. This again happens later on in events, but we will see how this triggers certain alerts and how business rules can be implemented to catch or to trigger these alerts. Let's go ahead and start the simulation. Again, I'm going to adjust the time compression just to allow enough time to speak about what is happening. Moving back to the trip details, we should be able to see the vehicle start to make its way along the route. Once it stops unexpectedly, round about here, we will go to the Vehicles tab and view what happens with the doors. Navigating to the Vehicles tab, keep an eye on the vehicle diagram as well as the alert location. Alert panel on the bottom left. As you see, the perimeter alarm has been raised. At this stage, I would like to just pause the simulation quickly and speak about what is happening. There are various rule modules that can be implemented in order to provide business rule alert raising. Here, we are interested in the trip stop perimeter violation rule. Let's go ahead and click on that to view some more details. As you can see from the description, it is used to determine if a trip is stopped outside of the stop perimeter and the doors have opened. There are certain parameters that are provided in order to trigger this alert. By clicking on one of the event parameters, you can get a short description of what it does. For example, the time in seconds that a trip is over the threshold speed before marking a stop trip is running. But these don't make a whole lot of sense in the current context. So let's navigate in the left menu to the configure option. Here we can click on events and view the different events that are implemented for this specific context. We are currently interested in the position trip and trip stop perimeter violation. If we now examine the parameters that are defined, we can now see that there are different values that are defined for the parameters. In summary, these determine if a trip is stopped if it has been moving at 10 kilometers or less, as seen by the threshold speed, for 2 minutes or more, as seen by the 120 seconds threshold below time delta. That is how we know that the trip has stopped and that an alert should be raised. Furthermore, we can see that a trip is no longer stopped once it is moving greater than 20 kilometers an hour, as seen by the threshold above time delta, for more than 150 meters, as shown by the threshold above distance. This is just to demonstrate that various rules can be put in place to custom rules in order to let the end user know that something has happened and bring their attention to it. Navigating back to the the trip details, we'll continue the simulation. We will now see the vehicle continue along its path, and once it gets to the first stop and the doors open again, you will note that there's no alert that is raised. Here we can see, might be able to catch. I missed it, but the vehicle's doors would have opened and we would be able to see that in action. As you see now, the vehicle has again moved over one of the high-risk areas, so therefore an alert is raised. Let's move on to the next test case. I will terminate and reset this simulation. Select the test service date again. And for this, the final demonstration for this context, we'll have a look at a single trip with an off-track external rule. As we can see again from the description, once the vehicle deviates from the trip, an alert will be raised, and we will see it deviate from the planned path. Let's go ahead and start this. So what you will observe is the vehicle following the planned route. Shortly after, it deviates from the planned route and an alert is raised. Once the vehicle then returns to the planned route, the alert will be ended but not dismissed. And again, after a brief moment of passing over the planned route, it deviates again before returning to the planned route. If we select one of these alerts that have been raised, one additional detail to note is that we have the alert start and alert end time. These can be used to represent the time that the vehicle deviated from the planned path, as well as the time that it rejoined the path. This concludes the current context demonstration. So I will reset this and move over to the virtual train demonstration. Logging into the virtual train context, we can now see some different information displayed on the, again, default map visualization. We can see a railway system in the Netherlands with the railway lines identified as purple lines on the map and the various train stations as stops identified as blue train icons on the map. We can then click onto one of the train stations and view some additional information. As you can see, it's similar to the first context where there's not a whole lot of information until we start running the simulation. So let's go ahead and do that. For this test case, we'll have a look at an on-time return trip with multiple train sets. Firstly though, we can see that there is a large number of different test cases that are provided for this virtual train context. So it's worth exploring further. However, for time constraints, we will only examine 2 of these test cases. So I'll go ahead and select that test case. As we can see again from the description, there's 2 trips with multiple train sets on each trip from Amsterdam Central to Dordrecht, and a single return trip from Dordrecht to Amsterdam Central, also with multiple train sets. The return trip has a dependency on the train sets from both of the inbound trips, and all trips will operate to schedule. Let's go ahead and start that and observe what happens on the map. Let's go ahead and select the first trip to view the details. Now you may notice that in addition to the departure and arrival times, we now have a third column. This third column identifies the platform details, the platform number. This just goes to show how all of these contexts can be customized to any of the applications or business applications as defined previously. We can now see that our cargo has changed to passengers, and therefore our capacity status has now changed to people and the relevant compartments in the train. We again can see all of the standard information on this page. So let's go and have a look at the vehicles. Now we are presented with a really interesting diagram of the train. You now will be able to see the different compartments by a color-coded status showing their available capacity. As you can also see, this trip has 2 train sets assigned to it, the first of which is shown above, followed by the second train set. As the trains go from stop to stop, these values will be updated automatically, and the few seats available status will change according to the capacity on the train. I would just like to reset this quickly to allow for the simulation to run again. Once the trip starts up, apologies, I've selected the wrong one. So starting up that simulation again, I'm going to navigate to the Cruise tab of this specific trip. And here again, we see that our crew is context specific. So now we have a garden operator. We see again where the trip has originated from and the specific shift they're on, or shift ID. We can also click on a crew member and we could see where they are in real time. We can also view information about their shift. For example, schedule information and additional properties and alerts. Although in this context, none of those have been defined. Lastly, in terms of the tabs in the vehicle details, again, there's no properties defined for either of these contexts. However, custom properties could be defined here in future. And in terms of the charts tab, we can see similar information to that which we saw in the Spotfire analysis. However, these are predefined chart types where we could see, for example, progress over time, occupancy distribution, and occupancy over time to view the different stops and how full the train gets over time. Lastly, let's go and have a look at what happens with a delayed train test case. So I'll go ahead and reset this. We'll go ahead and select a delay, single trip, return trip, if I can find it, with a multiple train set and departure delay. In this test case, we're just going to demonstrate what happens when we have a delay from the first departure location and how that rolls over to the rest of the train stops. So navigating back to the home screen, we can select, again, the same trip. And we can clearly see from this trip information once it starts that the train is delayed. And from there, we can see how the scheduling information changes. So there we see that it is now delayed by 5 minutes. And therefore, incoming at the next station, it would be 5 minutes late. Plus, we get an additional, I believe, 5 minutes or 7 minutes before it makes its way to the next stop. And so it goes on until the end of the trip. One important observation to make is the status of the train stations by the delayed schedule. As you can see in this test case, all of these train stations are now labeled as red because of the delay that is occurring at the specific station. If this was on time, these would be color-coded as green icons. This concludes the demonstration of the virtual train context and the demonstration of the live view dashboard. There are many more contexts to be applied into this virtual train context. However, it would require additional demonstration time. Thank you for watching, and I hope you enjoyed it. If you have any questions, please feel free to ask. Otherwise, the control is back to you, Arsene.
Okay, thank you, John T, for this amazing presentation.